The average rate of change of a thrown rock's height is a measurement of the rock's average speed. It measures how fast the rock is moving over a period of time, say from 1 to 3 seconds. We calculated the slope of the secant line earlier in order to calculate that average speed. But that doesn't tell us much about how fast the rock is moving at say t is equal to 1 second or t is equal to 3 seconds, a specific point in time. What we need in order to calculate that is the instantaneous rate of change, or the instantaneous speed. In order to calculate an instantaneous speed, you need to use not a secant line, but tangent lines. Tangent lines brush the graph at the point you're trying to calculate the instantaneous rate of change. I've drawn a whole bunch here, and you can see that it brushes the graph because it only crosses that point once around that function. Now, calculating slope of a tangent line is not particularly difficult. You just have to take 2 points on that tangent line and use rise over run. The challenge is that drawing tangent lines can be really inaccurate without the use of a graphing technology. So some people might draw the tangent line like this. Other people might draw the tangent line like this. So you're going to get different calculations depending on who drew the tangent line. But what the tangent line can help us do is analyze trends in the graph. So I've drawn a whole bunch of tangent lines here. One thing you can notice is that the slope of this line is 0. Remember that an instantaneous rate of change measures the rock's instantaneous speed. So why is the speed 0 here? Because it hits its max height. At its max height, the ball needs to stop in order to turn around. So that's why the slope is 0 here. You can also see that the tangent lines to the left of t is equal to 1, those would all be positive. These are positive slopes because they go up and to the right. All the tangent lines to the right of t is equal to 1, they all have negative slopes. They're going down and to the right. So why are the slopes positive to the left of t is equal to 1? Because it's rising. It's going upwards. Why are they all negative over here? Because the function is decreasing. It's going downwards. There's one other thing you can notice here, is that the tangent lines to the left as t is equal to 1, they seem to be getting shallower. Okay? Why are they getting shallower? Because the slope is actually decreasing, or the speed is decreasing. The ball is, yes, going upwards before t is equal to 1 at its max height, but it needs to slow down. After t is equal to 1, look at the slopes. They tend to get steeper and steeper. That's because after it achieves its max height, the ball only gets faster as it goes down. So while calculating a tangent line can be really difficult to get an exact number if you draw it by hand, it does help us to analyze trends in the graph.